The Earth, our home planet, is in a state of perpetual motion, executing complex movements that contribute to the cyclical patterns of days and nights, seasons, and even the stability of climates across the globe. Understanding these movements not only sheds light on the Earth's dynamics but also elucidates the intricate balance that sustains life.
The rotation of the Earth is the spin of the planet on its axis. An observer from space would see Earth rotating from west to east, completing a full 360-degree turn approximately every 24 hours. This rotation is responsible for the day-night cycle, a fundamental time measure for all Earth's inhabitants.
The Earth rotates because of the angular momentum conserved from the planet's formation. When the solar system formed from a rotating disk of gas and dust, the conservation of angular momentum meant that the disk's rotation speed increased as it contracted. The Earth, formed from this disk, retained this rotational motion.
The rotation of the Earth results in several phenomena. The most direct consequence is the alternation between day and night, affecting the rhythm of life for most organisms. Furthermore, it causes the Coriolis effect, which influences wind patterns and ocean currents, playing a crucial role in weather systems and climate.
The revolution of the Earth is its orbit around the Sun, taking approximately 365.25 days to complete a full circle. This movement is pivotal in determining the sequence of seasons and affecting the distribution of sunlight across the planet.
Earth's revolution around the Sun is the result of the gravitational forces between the Earth and the Sun. According to Kepler's laws of planetary motion, Earth follows an elliptical orbit, with the Sun at one of the focal points. This elliptical orbit means that the distance between the Earth and the Sun changes throughout the year, affecting the intensity and distribution of sunlight.
The revolution of the Earth has profound implications for the climate and ecological systems. The tilt of the Earth's axis, about 23.5 degrees from the perpendicular to the orbital plane, in combination with its revolution results in the changing seasons. Regions experience seasonal variations in climate and daylight hours, impacting agriculture, wildlife migration patterns, and human activities.
Precession is a slow, conical movement of the Earth's rotation axis. This movement, akin to the wobble of a spinning top, is caused by the gravitational pull of the Sun and the Moon on the Earth's equatorial bulge. The cycle of precession completes approximately every 26,000 years.
The mechanism behind precession involves the gravitational forces exerted by the Sun and the Moon on the Earth's equatorial bulge. These forces create a torque that causes the Earth's axis to precess. The phenomenon can be understood by considering the Earth not as a perfect sphere but as an oblate spheroid due to its rotation.
Precession affects the Earth's climate over long periods. It alters the timing of the seasons by changing the orientation of the Earth's axis. Over thousands of years, this can lead to significant climatic shifts, contributing to natural climate change cycles, such as ice ages. Moreover, precession changes the pole star. Currently, Polaris is the North Star, but due to precession, other stars will take its place over millennia.
The movements of the Earth are not isolated phenomena but are deeply interconnected, influencing and regulating the planet's climate and ecological balance. For instance, the combination of Earth's rotation and revolution determines the pattern of seasons, while precession introduces long-term changes to these patterns.
The interplay between rotation, revolution, and precession has profound implications for Earth's climate systems and biodiversity. Seasonal changes drive the breeding patterns of many species, migration cycles, and plant photosynthesis rates, which are essential for life on Earth. Additionally, these movements affect the distribution of solar energy, which, in turn, influences weather patterns and ocean currents, key components in the global climate system. Human societies have adapted to and been shaped by the Earth's movements. Agricultural practices, for example, are closely aligned with the seasonal cycles, dictating planting and harvesting times. Moreover, understanding Earth's movements has been crucial for navigation, timekeeping, and calendar systems, underscoring the deep connection between human civilization and the celestial dance of our planet.
Floods stand as one of the most common natural disasters, affecting millions of people worldwide annually. Their impact ranges from mild inconvenience to devastating destruction, leading to loss of lives, destruction of infrastructure, and significant economic losses.
Floods can occur through a variety of mechanisms, each differing in speed, duration, and destructive potential. The primary causes include: the most common cause of floods is excessive rainfall that overwhelms the drainage capacity of an area. Urban areas, with their vast expanses of impermeable surfaces, are particularly vulnerable to flash floods due to rapid runoff.
Rivers can overflow their banks when excessive rain, snowmelt, or a combination of both leads to water levels rising above the riverbed. Such flooding tends to be more predictable and may last for days or weeks, affecting larger areas.
Coastal areas are susceptible to flooding from storm surges caused by hurricanes or typhoons. The surge, combined with high tides, can lead to seawater inundating low-lying coastal regions. In colder climates, ice jams can lead to floods. These occur when pieces of floating ice accumulate at a natural or artificial barrier and prevent the flow of water, causing it to overflow the banks.
Though less common, the failure of dams and levees can lead to catastrophic floods. Poor construction, lack of maintenance, or natural events like earthquakes can lead to dam breaches, releasing massive quantities of water downstream. The impact of floods is extensive, affecting individuals, communities, and entire ecosystems.
The immediate human toll of floods includes loss of life and injury. The destruction of homes and displacement of communities lead to long-term socio-economic challenges. Floods disrupt livelihoods, particularly in agricultural communities, where the loss of crops can lead to food shortages and economic instability.
floods can have a significant environmental impact. They can lead to the erosion of valuable topsoil, contamination of water sources with pollutants and waste, and destruction of habitats for wildlife. However, floods also play a crucial role in natural processes, such as replenishing wetlands and distributing nutrient-rich sediments.